Welcome to this electrical installation training video from the Focus Training Group. Today we're going to take a quick look at cable selection as part of the Level 3 electrical design. In particular, we're going to have a look at design current. First up, let's see what design current is. If we take a look at BS 7671 2018 Part 2 definitions, it tells us that design current is the magnitude of the current, RMS value for AC, to be carried out by the circuit in normal service. Just a quick recap on RMS, so root mean squared. So the RMS value for AC is, basic terms, the smooth DC equivalent. In simple terms, the statement here is telling us that design current is the amount of current, or amps, we expect our equipment or our circuit to draw for its normal operation. If we take a look in the symbols of Part 2 of BS 7671, we can also see the symbol given for design current is a capital I with a lowercase b. Tells us this is design current of a circuit and it's measured in amperes, amps, and uses the symbol capital A. How do we find design current? Well, the formula we're going to choose will depend on our supply voltage, whether we have single phase or three phase. So we can see the bottom left we have our single phase formula, which says IB, which is design current, is going to be equal to power in watts divided by U, which is our nominal voltage. Then for three phase, slightly different, we can see design current is going to be equal to power in watts again, divided by root 3 times our nominal voltage. Let's have a look at some examples. First up we have single phase. So we can see our single phase formula, top right, power over 230 volts, because we're talking about the standard domestic supply in the UK. And in our example it says a 3 kilowatt heater is to be connected to a single phase supply. What is IB, or what is design current? Bottom left we can see where we put the figures in, so we've got design current, IB, is going to be equal to 3000 watts. Remembering that in our question it says 3 kilowatts, but of course we need to use our base units. Our base unit for power is watts, so we've had to convert that into whole watts. So we have 3000 watts divided by 230 volts. That gives us our IB of 13.04 amps. Next up, we'll have a look at a three-phase example. Top right again, we can see our three-phase formula, power in watts divided by root 3 times 400 volts. Our example says 4.5 kilowatt load to be connected to a three-phase supply. What is IB? Bottom left, we can see IB, design current, is going to be equal to 4,500 watts, remembering to convert from kilowatts to whole watts, divided by root 3 times 400. We can see in the middle, we've redrawn that formula, so it says 4,500 watts divided by 692 volts. So we can see that is the product of root 3 times 400. And then finally on the right, we can see the outcome of our formula. It gives us 6.5 amps. Just bear in mind that the first example we saw, example 1, was for 3 kilowatt heater on a single phase supply, and we had a design current of 13.04 amps. Then for example 2, we've actually got a higher load. We have a 4.5 kilowatt load, but because it's three phase, we've actually come out with 6.5 amps as our design current. Just bear in mind that that does actually mean 6.5 amps per phase. Finally, we'll take a look at a third scenario where we may need to consider power factor. Typically, inductive loads such as motors will produce a power factor value, and we need to think about this when we're carrying out our design current calculation. We will explore how we calculate power factor in a later Science and Principles video. For now, we just need to recognise that the power factor value will be given on the manufacturer's instructions or perhaps the rating plate of a motor. For example, 16 kilowatt motor has a full load power factor of 0.8. What is IB? Bottom left we can see the formula, so we have IB, design current, is going to be equal to power in watts divided by root 3 times 400, because we're talking about three phase, times cosine theta. Again, in a future video we'll explore where we get this value from, but for now we'll just recognise that we put in the value of power factor from our question where it says cosine theta. In the middle then we can see we put in the figures, so we have 16,000 watts, remembering to convert from kilowatts in the question, divided by 692 volts, the product of root 3 times 400, and times by 0.8, our value of power factor from the question. You can see then our outcome for IB is 28.9 amps. In some subsequent videos we'll explore some more about design current, where we take into consideration diversity. And next up we're going to have a look at how we're going to select our protective device from the value of design current. See you next time.